So these are the things we have to cover. I mean, I will obviously touch each and every point. That is introduction to MLOps. Then we'll see what are the main challenges that we are facing. Then the journey from DevOps to MLOps. Then we'll talk about MLOps process. Then why MLOps? What is MLOps and all? How is MLOps different from DevOps? Then what are the best practices of MLOps? Then we'll talk about ML machine learning lifecycle management. Then we'll see what are the tech stack, what are the technology involved in MLOps. Like as part of the journey, if a person wants to study this, what are the different tools and technology he will learn as part of this journey? Then what are the prerequisites required to learn MLOps? This is a, I can say, obviously, it's a first question trigger in your mind. Sir, if I want to do this course, what are the prerequisites required? What are the different tech stack I should know before in hand? That also will see. Then I will show you a dedicated curriculum that we have designed as part of this particular plan. Then we'll see each and everything. Okay. Introduction to MLOps. Guys, before 10 years back, I mean, whenever a person is claiming that, he's saying, I'm working software or IT field, basically he or she want to represent as themselves as a software engineer or software developer, right? Software developer, or I can say software engineer. What is their main task? Their task is to develop a beautiful software. Those teams basically they claim themselves as DevOps team. DevOps. So if I write what is DevOps, DevOps is nothing but the combination of two different words, that is development and operation. Development and operation. Okay. Similarly, nowadays, from last 5 to I can say 7 years, there is another I can say job market booming actually, which is just revolve around the data. Okay, all are related to data, only data field only. If you write data, so lot of job profile evolve just within last 5 to 7 years. What are those? There's a field called DA. What is DA? DA stands for data analyst. Similarly, there is a field called DE, that is data engineer. Similarly, there is a field called DS, data scientist. Another things coming to market, that is MLE. People are claiming them as machine learning engineer. Similarly, there is another job profile called MLOps, which we are going to discuss as part of our agenda. Okay. Then a lot of other people also. I am not, writing each and everything. You might have heard that is AI engineer, DL, deep learning engineer, NLP engineer. Okay, a lot of things are there. Okay, I'm not writing all of this. Okay. Now, similarly, the first person who is working on machine learning field, like the person who is working in machine learning field. So, machine learning engineer is MLE. I can write. What is their responsibility? They are trying to build the application, which is application is not a normal software application like how a software developer is developing, right? This is called machine learning application. Machine learning application. Here also, same 3 pages we are following: QA, production environment, and we have something called dev environment. Okay, no doubt in dev environment, a machine learning engineer is developing a machine learning application and all. Once he has completed the development part, it will move to QA part for the testing and all. Okay, so QA testing will happen. Okay, testing. Once testing has been completed successfully and they give the green sign of signal, then it will go and move into production for the production deployment. So basically, it's a production. Now the team, the person who is claiming themselves as responsible, they're taking care of the responsibility of the machine learning application deployment. They themselves call us. We are belongs to MLOps team or MLOps. Then what is the full form of MLOps? So MLOps is the combination of, again, two different words. Sorry, that is ML plus operation. ML stands for machine learning plus operation. Okay. Now there's a question comes to your mind, sir, is it DevOps same as MLOps? Because there is no difference, right? You're telling DevOps is nothing but a combination of development and operation. Here also same, MLOps is nothing but machine learning and operation. The person who is taking care of deploying not only just simply a software application, but also the machine learning application. Then the people are called as MLOps instead of DevOps. But that is a wrong answer. MLOps is not same as DevOps. MLOps not same as DevOps. It's too far away from DevOps. What is that? We'll discuss today as part of our agent today's journey. Okay, MLOps is too far from DevOps. The things we can, what we can do in DevOps, same things we can achieve by using MLOps. But in addition to that, some other things that we are doing as part of MLOps, which we are not doing as part of DevOps. That I'll show you. Okay, nothing to be of. Let's move to second one. That is main challenges. Fine. So for that, let me share my PPT. What are the main challenges? Now, publishing a machine learning model is not enough. After publishing also, publishing in the sense like after deployment to production cluster also, we need to manage it, means monitor it, and we have to maintain it, which is a tedious process, which is not that much easy. And it's not like that a person have to sit always and they have to observe 24/7. Any failure will happen or any number of executor I need to increase and now. Let me give you a practical scenario which I have faced as part of my journey, my organization itself. We have developed an application. So while developing the application, we have assigned some executor. Let's say number of executor we have assigned a six number of executor. Whenever we move to QA, in here we maintain the same because the data volume was not that much great. Because whenever we develop any application, okay, we just take a dump of data from the production environment. Just some sample of data, let's say 10,000 data, 20,000 data, something like that. We will not play around with TV data and all for development purpose, right? Then testing again will increase little bit, huge amount of data set so that we can do rigorous testing, and all corner cases and all. Fine. But in production, guys, it is 10x time volume or 10x time of the development data that we have taken. Right? For example, you are developed the application on top of 10,000 data or 20,000 data, but in production it may be 1 TB data, 2 TB data, or whatever maybe. It's too high. So whenever we move to production deployment and we have assigned the same executor, number of executor, that is 6, we have seen initially 4 to 5 months it was fine. One day that job got failed. Then we started the root cause analysis. Why all of a sudden the job got failed, even though it was running or working fine from last 4 to 5 months or 3 to 4 months in production environment. Then we got to know exactly in that before night, the data volume got exponentially increased. Then at that time, whatever the number of executor I have assigned, that was not in a position to handle those huge amount of data because I have assigned only 6 executor. And why 6 executor? Because I have started when I have developed, I have developed with the 6 number of executor. That I move with the QA, then after QA I move to the production. But I forget that there's a chance that in production number of volume of the data will increase going forward. Because whenever we develop an application, for example, new customer are onboarding, right? So I have to keep on adding those details in my database. Obviously, data volume will increase. Then at that time, that is the reason why it got failed. Then what is the solution? It's like one person have to sit and he have to observe that when data volume will increase, he will manually assign the number of executor, and when data volume will decrease, then he will release the number of executor. No, that is not possible. Then we figure out a solution which was given by almost all the cloud environment, but we are using the Databricks and all. There is a concept called auto scaling concept. What do you mean by auto scaling concept? Auto scaling concept is a technique, I can say, by using which automatically the infrastructure will take care of the assignment of the number of executor based upon my requirement, and releasing the number of executor based upon my requirement if data volume is less. For example, like as I have moved to the production environment, let's say today my data volume is, let's say, 20K. Let's say, and 20K data, to handle 20K data, 6 number of executor are enough. Okay, now it's running 1 month, 2 months, it's working fine. After 6 months, let that data volume increase from 20K to, let's say, 80K. Okay, 80K or maybe 70K or 90K. Now, those 6 executors are not enough to handle 90K data. Maybe it requires another 4 executors. Now, who will assign that executor? If I have enabled the auto scaling concept, then automatically 4 number of executor will be used in that process, which is readily available, not used by any other resource. Then now I am not using only 6 executor, 6 plus 4, 10 executor I am using as part of my infrastructure. Now 10 executor are enough to handle 90K data. Now that is a reverse situation. For example, sir, let's say after 1 month, again the data volume reduced from 90K to, let's say, 50K. Is it like I have to use all the 10 executor? No, that is again you are misusing the resources. Because you handle 50K data, you really don't need 10 executor. Maybe within 7 executor you can complete that. Then it will start releasing another 3 executor. Now it will drastically reduce down from 10 executor to 7 executor. So automatically it will take care of the scale up and scale down activity. That is the concept of auto scaling. So how you will implement such type of things? It's not possible to do manually, right? A person will observe every time if data volume increase, it will start assigning. If data volume will reduce, it will start releasing the executor. No, that is not possible. So to automate that, we have to implement MLOps. Obviously, we have different tools like MLflow, Kube2, and all. We'll see as part of our journey that is taken care by them. As a developer, I no need to worry about that. How to assign, how to release, when to assign, when to release. I no need to worry. That's why only deployment of machine learning model is not enough. Don't think that I have developed, I mean machine learning engineer they have developed as a MLOps engineer, I just deploy into production process, that's all. My work is done. No. After that is our duty also to monitor it, to maintain also. Sometimes, like as data volume will keep on increasing, the model performance will goes down. For example, initially when I have developed the model, it is giving 92% accuracy. 5 years, 5 months, 6 months, 8 months, or 1 year, 2 year down the line, you see the model performance decreases from 92 to let's say 85%. Then I cannot always run with that, go ahead with that 85%. Then again, I have to retrain the model on top of the new latest data set. I have to retrain it, I have to fine tune it, again, I have to redeploy it. So those kind of maintenance activity, monitoring activity, also kind of post-production activity, I can say. There's something called pre-production activity. What are things I need to do before moving into production or deploying to production? Like that, there are certain tasks are also there which I will take care as part of post-production activity, which post-deployment activity, I guess. So those things also as part of our journey. Okay, now let's move to the next, the journey from DevOps to MLOps. Okay, so we'll try to understand and we'll see as part of this journey how MLOps is different from DevOps and how it is too far away from DevOps and all. It's not like that exactly said. Yes, I will agree. Whatever things you are doing by using DevOps, same things you can do by using MLOps. But apart from that, you can do lot many other things, which is not you can do by using DevOps. Fine. Now you can see this is the typical MLflow machine learning process. Let me maximize. Yeah. So before starting doing any coding or developing any machine learning model, first we need to understand the business problem step. If you are from machine learning background, you know we have different machine learning model to solve different problem statement. So which machine learning model I need to use to decide that? I need to understand my business problem statement, whether it is a regression problem statement or classification problem statement or clustering problem statement, or it is a recommendation system I have to design or forecast time series forecasting and all. Those things we have to decide by understanding the business. Then I'll take, okay, this is the kind of classification problem statement. Then I'll see what are the different classification algorithms are there to solve a classification problem statement. It may be logistic regression, it may be decision tree, it may be random forest, it may be XGBoost, it may be support vector machine and all. Then I will implement all sort of machine learning algorithms that are available or that I know. Then by using K-fold cross validation, I will try to pick which machine learning model is best suitable for my problem statement based upon different by using different hyperparameter tuning. I will enhance the accuracy and I will consider different type of evaluation metrics as well, precision, recall, reference score and all. Based upon that, I will decide which machine learning model is best suitable for this problem statement. Then before that, as you know, before I develop the machine learning model, I have to collect the data collection, data pre-processing. Then I have to inject into my raw layer or staging layer. Then all sort of data pre-processing activity, data cleaning, data mining, data wrangling, everything else. Then by using different type of visualization tool, maybe Tableau or Power BI, or maybe by using the library given by the Python, maybe Matplotlib and Seaborn, I will create different type of visualization report to show to show to my end client to take the business decision whether whatever data we have that is more than enough to proceed to build a model or we need more data or you need to drop any unwanted column or you need to add a column. Those decisions will be taken care of this process. Once we get a green sign signal from the client, yes, please go ahead to deploy the models and all. Then we'll start, going ahead to deploy, building the models and all. So as part of the model building, we are doing feature engineering, feature selection, model training, hyperparameter tuning, then model evaluation or prediction we are. Once it is done, then we will go ahead and deploy the model in any of the cloud that is used in our organization. There is no, restriction that you have to deploy only in Azure or only in GCP, only in AWS. Whatever, maybe your company is using AWS, then go ahead and use in AWS cloud. If your company is using Azure, then go ahead and use the Azure cloud. So once you complete the deployment part. Then the post deployment activity will start. That is monitoring, maintenance, and debugging. When debug, you'll do the debug. For example, it got failed, the job got failed. All the accuracy dropped down. What is the accuracy you are getting as part of development of QA, but after deploying to production, your accuracy goes down. Then you have to start debug. You have to work on root cause analysis, why, all. Then again you have to retrain. Retrain on top of what? Again you have to collect more amount, a huge amount of data as part of data pre-processing and all. Then on top of those new data, huge amount of data, again you have to train. Same process you have to follow, kind of loop kind of things. Data integration, then data pre-processing and cleaning. Then again you have to go for feature engineering, feature selection, model training, hyperparameter tuning, then evaluation. Then again you deploy. Now you see, obviously before to the previous stage, now your accuracy will be increased. Let's say previously after deployment, it was like 78%. Now it become 85. Because 85 is good for time being. If your manager tells no, we need at least more than 90 to 90. Then again you have to retrain by collecting more new set of data from the different sources. Then again, you have to inject it to the staging layer, then do the data processing and cleanup activity, then do the data visualization, then do feature engineering, model training, hyperparameter tuning, model evaluation, then again go for deployment and all. Now we got 95% accuracy. Now you can stop. You might say, yes, that's enough to continue for next 6 to 8 months or 1 year. Let's see if any our accuracy will drop down, then we'll see we'll go for retraining and all. That's the entire ML flow we do follow. Right, moving to the next. Why ML offsets? There are a lot of advantages out there in MLs, obviously apart from this, but I have just highlighted few of them, which are important. Okay, it's talking about the agility, continuous and faster delivery, faster modification, and faster bug fixing also. Because we are using different open source tool which is taking care of end-to-end flow, starting from tracking the code, tracking the data. Like as part of this tool also we are using DBC, data version control. You might have heard about GitHub and Git and GitHub, or maybe GitLab or Bitbucket. That is for code version. If you want to store your code as a central repository so that your team member can access, you are using different kind of code hub or code versioning tool. That is example I can say GitHub, GitLab, Bitbucket and all. Similarly, for data versioning, to maintain different versioning of data, we are using a tool called DBC, data versioning control. That is also a tool which is included in MLOps and all. Then experiment, faster and control experiment, faster integration of successful experiment to other environment as well. You can integrate any other third-party tool with MLOps. And you can see, for example, as part of MLOps, you got the accuracy you want to see, you want to track it. You can integrate other third-party tool. Or at the output you want to showcase as a part of visualization, as I told you, you can integrate with a Power BI or Tableau or any other tool also. Similarly, scalability. Easy integration of new ML model, standardization of the code, lower operational cost. You don't need high-end configuration. Commodity hardware is not obvious. Yeah, again, it depends. Like if it's just normal machine learning algorithm, then you can handle by using the CPU and all. But if you really want to deploy the deep learning algorithm as well, like kind of image processing and all, for that you need high-end GPU and all. Traditional system, for example, if you want to maintain anything in the production, you have to write a lot of script, maybe Unix script, Shell script, or Python scripting and all. But here it's not like that. Everything can handle or manage by using different kind of open source tool, or if you are using any cloud, then cloud also provide different services by using which you can manage those. Both will see. Fine. Now go to the next. Now I told you MLOps is not just like DevOps. Now it will be 100% clearer. After that also another slightly there. By that time you will be 100%. I've written in my whiteboard MLOps is nothing but combination of two different words just to make feel you easy because you can correlate with DevOps. Like DevOps is nothing but dev plus operation. Similarly, machine learning is nothing but ML plus operation. But guys, actually, frankly speaking, it's not the combination of machine learning and operation only. It is the combination of ML plus dev plus operation. That is MLOps. You can see as part of ML, machine learning, we are dealing with all sort of data pre-processing activity, data injection, data extraction. Then obviously, I have to decide which model I have to use. Then as part of development, obviously, I implement that algorithm to build or develop my model. Then verify, testing, everything, evaluation and everything I'm doing. Then as part of operation, I'm going and releasing. Releasing means I'm deploying in production cluster. Then after that, my work has not completed. I have to monitor it. I have to maintain it. I have to all the infrastructure, configuration, everything I have to take care. So that is a complete end-to-end flow, which is called as machine learning operation. Now you can see what are the things we are doing as part of this MLOps code development and all. There are two different, I can say, parallel work we are doing basically. People who are working here, generally, the typical work is taken care by data engineering team. Extract the data from different source system, building data pipelines, store into your staging layer, then doing all sort of transformation logic, data cleanup activity, data wrangling, data mining, column level mapping, handling null value, everything, dropping on unwanted column, then data type conversion on everything they are doing on the fly. Then they are making the data ready for building the models. Then based upon your business statement, you understand the business problem, you decide which model I have to use. It's a regression model or a classification model or a clustering model or like time series based model or recommendation system. What else? What is the things you want to develop? Then you are training your model on top of the data. Now your model is ready. Then obviously you are doing the by using hyperparameter tuning, you are using the doing your tuning, evaluation, prediction, everything. Then your model is ready for deployment. Clear? Now, this is what I was talking about sometimes before. What is MLOps and how is it different from DevOps? Now I think you will get 100% clarity. With DevOps, you can do short-term tasks, that is code versioning, because you are using GitHub or GitLab, Bitbucket and all. Fine. Then compute environment, that also you can track. Then continuous integration, CI/CD, continuous integration and continuous delivery, that also you can do. Then somewhat monitoring in production, somewhat, but by seeing, just look into the MLOps column. Same things, whatever you are able to achieve by using DevOps, you can do it by using MLOps. But in addition to that, lot of other stuff you are able to do by using MLOps, which you are not doing or cannot be done by using DevOps. What is that? Data provenance. I'll tell you what is that. Data set, like as I told you, managing DVC, data versioning control, how to manage different version of the data. Model, you have to store state of the model by using pickling and on-pickling. That also you are managing. By using hyperparameter tuning, you are enhancing the accuracy of the model. That is also taking care. You are using different kind of evaluation metrics like precision, recall, F1 score, accuracy, and all to compare between two different models. Okay, then the entire workflow, like CI/CD pipeline, you are writing the .yml file. In that, you are giving the entries or write down the script for CI, continuous integration, CD, continuous delivery, then again CD, continuous deployment. So basically, this is CI/CD/CD, continuous integration, continuous delivery, and continuous deployment. Okay, now you can see the end-to-end ML lifecycle management. Okay, now let's move to the next one. Let me maximize it. This is very, very important. From this diagram, you will get to know what are the different roles and responsibility of each and every team, because this is the entire end-to-end. And frankly speaking, guys, I involved in almost starting from data extraction till deployment. That is called, I can say basically cross-breed profile. Like if you have worked on data engineering, because before moving into data science, I was working as a core data engineering part. Even in Hadoop, big data, HDFS, I've also worked when I started my career before 8 years back as a data engineer. Then now I am working as a data scientist. Also, I'm taking care of data engineer. So I'm taking care of end-to-end flow, kind of full stack data science. We are we are interacting with the client to understand the business stakeholder. Then we gather the required data. Then we are taking care of data pre-processing part. Generally, it's taking care of data engineering. As I know, I'm also taking care. If you don't know, then there will be different team who will be taking care of this. Nothing to do. Then people who are working as a data scientist or ML engineer, like MLE, machine learning engineer, they are taking care of the model building, model training, model artifact is nothing but, think about after training, they have to predict or evaluate the model. Everything's fine or not. Then hyperparameter tuning they have to use to increase the accuracy. Then your deployment work start. That now you have to put to registry. Registry is nothing but where you have to register your model. Basically, in AWS, I'm using AWS, that is a service that it provides for ECR, Elastic Container Registry, where I'm registering my model, machine learning model. Similarly, if you go for open source, then generally people are using Docker Hub. You might have heard, right? You are creating the Docker image file from .yml file. Then you have to register your model in Docker Hub. Then from there, you can deploy into any cloud services or any other plan. Then once you deploy, then integrate, then operate means maintenance, monitoring, everything will go. So that will be taken care by MLOps engineer. So I've written software engineer means previously it's kind of think about DevOps and all. For software application, it is a normal DevOps script. Now for MLOps, like machine learning application, is MLOps engineer. So your work is just from starting from this. Once model is ready, you will take that model from the data scientist team or ML machine learning engineer team. You have to register it, or maybe they will just register. That's why you can see there's a cross. Sometimes they are doing. If they know, if they don't know, just you have to pick that model and register in the registry. Then you have to deploy. Then monitoring, maintenance, everything. Then again, as I told you, for example, you are not happy with the performance of that model. Your accuracy is not that much great. It's like 82%, 82. Again, you have to retrain. Then back tracing kind of thing, think about like feedback or back propagation. You have to start debugging, take another new set of data, then again data pre-processing, model building, model training, model artifact, register the model, then deploy, then maintenance, monitor, everything. Now you get, okay, your accuracy increased from 82 to, let's say, 89. But still, you are not happy. Client told, no, 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 I need at least 92% accuracy. Then again, you have to go back. It's a retraining, re-evaluation, remodeling, redeployment, everything will go till you reach your goal or till you achieve your goal. That is 98% or 99% according to the client requirement. Clear, guys? This is the entire process. So you are part of the process. Don't think that as a ML of engineer, you have to take care of everything. No. So that is my personal skill set. So I have the exposure to data engineering. I have the exposure to data scientist. I have also got knowledge or experience in ML machine learning operation. So I can take care of starting from here till deployment and all. And obviously including model retraining and all. But when you are here to learn machine learning operation, from you, the company expectation is just this point, last point you can see. From model registry till deployment, obviously, till monitoring, maintenance, and all. Okay, this part you can see. That's why I have highlighted MLOps engineer. You are taking care of this part, not data extraction, data pre-processing, model building, model training, predicting or evaluating model. No, it is not your responsibility. That is the responsibility of a data scientist or ML engineer, machine learning engineer, and obviously the data processing part is a part of data engineer account. Now, let's move to the next. Now, I have highlighted each and one a little bit one step deeper. Machine learning lifecycle management. Whatever I explained there, just a high level thing. Okay, data engineer taking care of this thing. Data scientist taking care of this thing. MLOps engineer taking care of this thing. But could you please tell me exactly what is happening? Exactly this is what is happening. Once you decide, so you have to train the tool. So once you receive the data, you have to split into two different segments. General people are telling two different segments: training data and test data. But guys, frankly speaking, in the real-time industry, you don't have to split into two different categories. You have to split into three different categories: training data, test data, validation data. Okay. Whenever you go to interview, generally, I mean, the book is knowledge. They're telling test data, training data, and test data knowledge. But if you tell the same things in the interview, happily they can catch you. You don't have any real-time experience, because people who work in real time, they know it's not split into two different category. It is split into three different categories. Training data, you can see training data, then text data, okay, then validation data as well. Now, sir, could you please tell me where is it used? Yes, training data you use to build your model. Now, once your model is ready, you have to evaluate, you have to predict on top of the test data what of the model you have developed that is a well suitable or good fit for your use cases or problem statement or not. Then once you have tested, you have to use a different type of hyperparameter technique to do hyperparameter tuning on top of what? Validation data set to increase the accuracy. For example, you have trained your model on top of training data set. You got 89% of accuracy. Okay, fantastic. Now, while testing on the test data set, you got almost 88 point some percentage accuracy. That's great. So no overfitting, no underfitting, nothing else. Perfect fit model. But are you happy with the 88 point something or 89% accuracy? No. Your intention is to increase the accuracy up to, let's say, maximum 95% or 94%. How to do that? You have to fine tune different type of hyperparameter. Then your accuracy will increase from 89 or 88 point something to 94 or 95. So how will do? And after changing the hyperparameter tuning, how will you test? You have to test on top of validation data. Then I told you choose the model. If I choose the model, for example, you are working on a problem statement to solve a classification problem statement. But to solve a classification problem statement in the world, we don't have only one machine learning algorithm. We have lot of machine learning algorithms. I can go for using logistic regression. I can go for using decision tree. I can go for using random forest. I can go for using execution and all. But how do I know which machine learning algorithm is best suitable for my problem statement? You cannot decide blindly. You have to use all the algorithms. Then by using k-fold cross validation technique or method, you have to decide which model is best fit for your problem statement. Because which model is giving the best accuracy. For example, logistic regression is giving 78%. Decision tree is giving 82%. Random forest is giving, let's say, 90%. Execution is giving 98%. So obviously, for your problem statement, execution work well. But don't think that always execute work well. Maybe your friend is working some other company. He's also working to solve a classification problem statement. If he's using all these 4, 5 algorithms, for him, maybe decision tree is giving more accuracy. So for him, you have to stick with decision tree. That's why choose the model. You have to stick with that model. Then you have to go ahead and develop that model only, like the model which is developed by using decision, not by using logistic regression or random forest or edge. Then once you deploy, obviously, I mean production plus production environment, then obviously other things will come like monitoring, maintenance, and all. That's why everything the sport model, production data you have to observe it, right? Monitoring and observing. Yes, deployment. Now let me go back to my whiteboard. Let's see up to what extent I have covered. So we have covered almost DevOps, this one cover, why, what, how ML are different, we have covered. Then best practices we have seen, then ML lifecycle management also we have seen. Now, the time has come to look into technology or component that we use as part of MLOps 6, right? technologies used in MLOps. Fine. Technology of the component used in MLOps. You can see. Let me maximize it. Also. Yeah, yeah. There are two different ways, guys, as I told you. There is something called open source. By using open source also you can do, and by using cloud platform also you can. For example, you want to go ahead and deploy into cloud environment. So I am just showing here for the, let's say, AWS. In AWS, there is a component called SageMaker. So simply you go ahead and upload your model to AWS SageMaker container. That's a deep learning container if you take. Now there is another way also. Without using SageMaker, there is a container called deep learning container. You might have seen here. Download, please have a option. So when you're doing deep learning container means you can deploy machine learning application, deep learning application, all sort of things related to machine learning. It's not like that you have to just deploy deep learning or machine. So it's taking care of everything. Then it will registry to Amazon ECR. Sometimes before I was talking, right? ECR, Elastic Container Registry, where you have to register your model. Okay, your model register has been completed. But where it will run? Where exactly it will run? There is another services called ECS, Elastic Container Services. Here exactly your model will run. But before model running, you have to register it. Before register, you have to upload to some container where it will reside. That is nothing but deep learning container. Similarly, there is another parallel way also. You can use EC2 instances, EKS services, and other deep learning ML. Now, sir, I'm not happy with that because whenever we use in a cloud platform or any services, a company have to pay because it's cost effective, right? It's not free. Based upon your users, company have to spend that much amount of money to the respective cloud provider, right? For example, you have to pay to Amazon. If you're using Azure, you have to pay to Microsoft. If GCP, they have to pay to Google. But generally, most of the companies they don't want to use any paid things, right? Because nowadays, lot of other tools are available in the market which is open source, by using which they can do the same task without freely. Why they want to spend huge amount of money for deployment purpose and all? That's why they are trusted to go for open source. Now let's try see what are the different tools and technology involved as part of the open source, by using which we can do the same stuff, model deployment and all, which also we include as part of our curriculum. So let's move to the next one. Yeah, you can see same diagram like previous one. You can see there is nothing is there open source. So I have added. You can say as part of open source, what we learn here, there is something called Kubeflow. There is something called MLflow, machine learning flow. It will take care of end-to-end flow. Each and everything you can track it. Okay, then there is something called Apache Airflow, which again is not part of our curriculum because that is for what I can say, for example, string purpose. So, for example, you deploy, you have to schedule, right? And what time job will trigger and all. So, for that, people are using VNC control them. Some people are using, Jenkins DevOps also. Like some people are using Street Data Collector tool. Some people are using Databricks also. Now, this is this is also open source. This is in Python script. That's a very easy. Okay, for knowledge sake, I've written. This was scheduling purpose, but for deployment purpose and all, taking care of entire ML flow and Q flow are more than sufficient. We'll follow this path actually. We'll learn as part of our curriculum. I'll show you anyhow the dedicated our curriculum that we have designed. Okay, what are the things we'll cover as part of this session? Okay, fine. Now let's move to the next one. How to create Docker image file, how to start, how to run, how to stop, everything. Then understanding of versioning control system, as I told you, GitHub and all. Just basic command. How to commit, how to add the file, how to push, how to clone. Any of those things also will cover, but if you have some basic understanding, then that is a good, I can say, advantage. Now let's come back. Let's go back to my whiteboard. Let me show you a diagram within 1 minute. You'll get much clarity what I'm talking about AI verse and all. Then I'll deep dive into the dedicated curriculum that we have designed as part of this course. Okay. Yeah, guys. So I was talking about this one. We have completed this part. Yeah. Let me draw. So this is the entire AI universe. AI means artificial intelligence, you know, right? I'll write each and everything, nothing to do. So let me write down AI. The subset of AI is nothing but ML, machine learning. The subset of machine learning is called DL, that is called deep learning. Okay, so AI means, let me write down intelligence. ML, machine learning. DL, not driving license. So deep learning. Nowadays, you might have heard about another popular terminology or buzzword called Gen AI. Gen AI, right? Gen AI. That we call generative, generative, generative AI. So where, sir, it is research? It is research here. Let me write down that one also. It is research part of the DL. Gen AI. Gen. So I will draw a ordering format, then I can say AI, subset of AI is machine learning, subset of machine learning is deep learning, subset of deep learning is equal to Gen AI. Then if you might have heard about other term, not to confuse you, you can see, sir, we have heard there is something called NLP. Where that is, we said NLP, nothing but natural language processing, which is part of deep learning, and another one is CB, computer vision. Computer vision. VISION. That is a part of this one only. This one only. So whenever I'm telling MLOps, Damodar, for you to give better clarity, don't think that we are just deploying this part, like this area. Only machine learning in this area. This only the application which was developed by using machine learning, algorithm. No, no, no. Because machine learning also contains deep learning and generative. That means by using ML also, when I'm telling ML ops engineer, they are also taking care of deployment of DL, deep learning algorithm. When I'm telling deep learning algorithm, it includes both. Okay, it may be the application developed by using NLP, maybe the application is developed by using computer vision, short I'm writing, right? CP. Or maybe it was a Gen AI, Gen AI application, possible. And or maybe machine learning, traditional machine learning, this area, red color area. This is also possible. This is Gen AI algorithm that is also developed. But as part of Gen AI, as we are evolving, there is something called LLM, large language model. Okay, and other things are there, LangChain, large language model, and all React system and all. For that, they are just giving a separation. They come up with some different latest tool. There is something called, another terminal is called LLM ops. LLM ops, large language model operation. It's a combination of LLM plus operation. But don't be confused. It's almost, I can say, same. For timing, you should not worry. Same things you can. Some advanced, in addition to that, some advanced tool and technology they have involved, and they told that there is another curriculum called, there is separate job profile called LLM Ops Engineer, which is taking care of dedicated to only GenAI deployment. GenAI. Because in GenAI, LLM involves, not in machine learning and deep learning. But same things, when I'm telling MLOps or LLM, there is no much difference, as I told you. Think about this is the elder brother of MLOps. MLOps. The same things you can do, some additional, some things are there, some latest tools and technology. That's, but both have the same ideas. So now, whenever anybody will tell MLOps engineer, don't only think, oh, only the application developed by machine learning. No, no, no. Now, Damodar, I hope you are getting 100% right. It can be take care of the application deployment, which is developed by using NLP, by using CB, by using GenAI. See, this is the dedicated course we have developed. It's around 40-hour course duration. Okay, you can see almost 13 different modules we have developed. Okay, let me go one by one from starting. So prerequisites, same things I have written in the PPT I have shown you. Okay, now come to the module one. We'll start from introduction. What is MLOps and all overview, everything. Like starting from Python. What are the things required to write a Python script as part of MLOps guys? Because Python itself is a heavy thing, right? Because to learn only core Python, it will take 2 to 3 months. So we are not here to become a Python expert or to become Python web developer. We are here to know the Python programming that is required to become MLOps engineer. So Python script and all, like different library like NumPy, Pandas, scikit-learn, everything we are covering here. Okay, Python for data science. What are the things required? Then EDA, exploratory data analysis, and all. That also we are covering. Then model development and training also. Different type of machine learning algorithm will use. We will train the model. We will evaluate and validation. Different type of hyperparameter tuning we are using. Then we are deploying. Then for that deployment, we are learning also one of the web development tool or technique of Python, that is Flash. You might have heard that is a Django and a Flash. So we are not learning Django here because Django is taking a lot of time. So we are learning Flash, by using which you can deploy your application. Okay, what is Flash and all everything. Then we learn about Dockers for machine learning. What is Dockers? Why Dockers? How to create Docker image file, containerize. Everything we learn from the basic. So once we complete, okay, then we'll move to Kubernetes. Okay, then what is Kubernetes? Okay, each and everything Kubernetes with working with Kubernetes kind and all everything will complete. Then now see, I was showing that open source tool like Kubeflow for MLOps in details, everything. See, everything we have covered in details. Then we'll go to ML. I will also showing as part of the open source. Again, everything, including CI/CD also. CI/CD for machine learning means in a GitHub action, we'll create the CI/CD pipeline, which will take care automated things like pick the model from dev environment, push to QA, then QA to production and all. We'll see how the script is running behind the scene. Then we'll see two different tools. One is a Grafana, another is a Prometheus. What is Prometheus? What is Grafana? That everything will integrate. Then I will show you overview because as I told you, I committed we are not going to reach any other cloud service because it's a cost part. Again, you have to give your credit card. Again, sometimes for happens and it will cost. So I will give you overview how we are using AWS ECR, SageMaker to deploy some notes and on dedicated PDF file I'll share with you. Okay, for this part. But anyhow, till this point, all the things practical with practical hands-on.